Hi y'all, my name is Paige Dean and my math topic project is about the Pythagorean theorem. I hope y'all enjoy. Here is the Pythagorean theorem by me, Paige Dean. What will we be covering in this video? First, we will talk about what is the Pythagorean theorem, why we use it, and the real-world applications of the Pythagorean theorem. What is it and why? What is it? The Pythagorean theorem is a rule in geometry that applies for right-angled triangles. Right-angled triangles are triangles with a 90-degree angle. Typically, the little box here is what indicates a right angle in a triangle. Why do we use the Pythagorean theorem? We use it to find the shortest distance between 2 points. The history of the Pythagorean theorem. It was named after Pythagoras, an ancient Greek mathematician who discovered it. We also have historical evidence that the Babylonians and Indians knew this concept early on. What is the formula for Pythagorean theorem? The formula for the Pythagorean theorem is a squared plus b squared equals c squared, but we can also solve for a or b depending on the problem using our algebra skills. What do each of these letters mean? So for leg 1 and leg 2, it doesn't matter, but you can pick A or B. However, C is the longest side of a triangle, which is called your hypotenuse. And typically they are opposite of your right angle. So here we have our right triangle. This side is 6 and that side 7. So we can identify those as A and B, or A and B. It doesn't matter. But we have to find C, which is the longest side. So we're going to use this formula right here. A squared plus b squared equals c squared, and plug it in with our numbers over here. So here we have 6 squared plus 7 squared equals c squared. So to figure this out, we're first going to put 6 squared, which is 36, plus 7 squared, which is 49. So after we add 36 and 49, we have 85, which equals c squared. However, to figure out for c, we're going to have to do the opposite of square and get the square root of 85. So we're going to take the square root of 85 and the square root of c squared, and that will be our answer. So after taking the square root of both, we get c on this side, and we get, it's not a perfect square, but we get 9.2. Here is a problem where we would work backwards with the Pythagorean theorem. Here we have b is 10, c, our hypotenuse, is 12, and here we need to find A. Once again, we will use our formula and plug in these numbers here. Here we have it plugged in. Since we don't know A, we'll just bring it down here. Since B is 10, it will go here as 10 squared. And our answer for C is 12 squared. So once we subtract 100 from this side, it cancels out. And then when we subtract 100 from 144, we get 44. So a squared equals 44. But since this is squared, we need to find the square root of 44 to find a. Once we find the square root of 44, we will know our answer for a. Our answer for a is 6.633. So a real-world problem of the Pythagorean theorem would be measuring your yard diagonally. The theorem tells you the shortest path from corner to corner. The Pythagorean theorem shows up everywhere for computers, architecture, sports, and space navigating. So we're going to work one out. As you can see here, we have a yard. Although it is square, we can pretend that it is just 2 right triangles. So say here, our yard is 8 feet on this side and 8 feet on this side. However, we want to know from corner to corner. And that's why we use the Pythagorean theorem. So to solve this first, we need to identify which one is A, which side is B, and which side is C. So here we have 8 is A, 8 is B, and we don't know C. So we're going to use the formula to solve for this. So here we have our problem set up. A squared, which is 8, plus B squared, which is also 8, equals C squared. So 64 plus 64 is 128. Now to find C, we must take the square root of both of these. After doing the square root of 128, we get 11.313 for C. The 3-4-5 method. The 3-4-5 method is commonly associated with right triangles and is a simple way to verify if a triangle is a right triangle. If the triangle has 3, 4, and 5 as its sides, it's a right triangle. Here we have a triangle where we do not know its angle. But this is how the 3-4-5 method works. Now we will use our formula to solve. Here we have our formula set up. Here as we can see, A and B together equals C. 25 equals 25. But what does this mean? So when A and B equals C on one side, just like this, that means it's a right triangle. Why does this work? The sum of squares on the two smaller sides in a right triangle equal the square of the longest side. Triples in Pythagorean theorem. Triples are a set of three numbers that perfectly fit into the Pythagorean theorem. The 3-4-5 is also a triple and is the most common one. Other famous triples are the 5, 12, and 13, the 7, 24, and 25, and also the 8, 15, and 17. You can also multiply triples all by the same number to get another triple. For example, with 5, 12, and 13, it could be 10, 24, and 26. Why are triples useful? They can help you check your work with geometry. They are also used in construction to make sure 90-degree angles are represented. And they are also commonly used in trigonometry. 3D version. There is a 3D version of the Pythagorean theorem. The formula is a squared plus b squared plus c squared equals d squared. Now each of these stand for a different thing in a 3D model. A is typically your length, b is your width, c is your height, and d is your diagonal line. Now we are going to work one out together. Let's pretend this square right here is a box. The length is 3, the width is 4, and the height is 12. First, we will need to find the base diagonal of the rectangular prism. To find the base diagonal squared, we will need to do a squared plus b squared. So we will plug in 3 and 4 squared, which will give us 9 plus 16, which equals 25, and that is our base diagonal squared. However, we will need to take the square root of 5 and the square root of base diagonal squared to find the base diagonal. Our base diagonal is the square root of 25, which is 5. Now we are going to use our base diagonal plus our height squared to find d squared. Now that we have plugged in our base diagonal and our height, we are going to find these two numbers squared. Now that we have found these two numbers squared, we're going to add these two together. D squared is equal to 169. However, we will have to take the square root of both of these to find D. After we take the square root of both, we have D equals 13. This means from this angle to this angle is 13. How is it used in trigonometry? For a right triangle, we use three primary trigonomic ratios: for sine, cosine, and tangent. So for sine, we have the opposite divided by the hypotenuse. For cosine, we have the adjacent divided by the hypotenuse. And for tangent, we have the opposite divided by the adjacent. Fun facts. There are over 400 known proofs of the Pythagorean theorem. One of these is the paper folding method that many people use. Trigonometry was founded on the Pythagorean theorem. Your GPS on your phone actually uses this every day, trying to find the straight line distance to your destination. It's also used in crime scenes too, with objects' positions and suspects' footsteps. Followers of Pythagoras, who founded the Pythagorean theorem, also had a secret club. The Pythagorean theorem is also a building block of the distance formula. The Pythagorean theorem is also found in art. Yep, you guessed it. Artists in the Renaissance era used this for perfectly geometric shapes. For example, Leonardo da Vinci uses this concept when making the human in the Vitruvian Man painting. This painting is still used today in the medical world. Conclusion. In conclusion, we have used the Pythagorean theorem for over 4,000 years now. Measuring yards, getting those even pizza slices, or even sending rockets to space just got easier thanks to a squared plus b squared equals c squared. The Pythagorean theorem is a key concept that we will forever use. Thank y'all guys so much for watching this video, and I hope you guys learn more about the Pythagorean theorem.